Assalamualaikum and good evening. I am Mohamad Syahmizzan bin Muhammad Saliman, one of the Stella members, and I'm here to introduce my team members. So first and foremost, I'm willing to share with you our project that requires us to design a product or system that can implement an efficient harvesting and pesticide spraying system at Sungai Marong Agri Farm, where currently they use a fully manual system for harvesting and pesticide spraying system. I'm glad to present our Stella Harcide design, which combines two essential functions, which are harvesting system and pesticide spraying system. So the advantages of our product, the first one is it is versatile and with its dual purpose design, allowing you to handle both harvesting and pesticide spraying with one machine, and farmers can use the same machine by maximizing its utility. So the second one is it is cost effective by reducing initial costs, maintenance costs, and storage requirement. Instead of purchasing and maintaining two different machines, farmers can invest in one versatile trolley. Lastly, it is user-friendly with a semi-automated system and easy control to operate, making it accessible even to those with limited technical skills. Our product stands out due to its material selection to ensure optimal performance. The main part of the product is the frame. It is made of galvanized mild steel and chosen because of its high strength to withstand a heavy load from the harvested crop. For the pesticide channel, we use PVC polyvinyl chloride, which is long-lasting and rust-resistant, ensuring reliability over time. The tires are made of rubber, providing excellent traction for smooth movement across the rain shelter, and it can avoid slipping. Finally, the nozzle is made of brass, known for its corrosion resistance, making it ideal for handling pesticides safely.
So this is our flowchart for harvesting system. It starts with turn on the switch first. After that, the ultrasonic sensor at the back will check the distance between the trolley and operator. If the distance is 40 cm or less than that, the trolley will stop. However, if the distance is more than 40 cm, the trolley will follow the operator. So this cycle continue as long as the switch remain on to ensure that the trolley follow the operator closely without getting too close and moving too far. So for the mechatronic analysis, this is our flowchart for pesticide control mechanism. So it starts with turn on the switch first. After that, the trolley will move forward for 5 seconds. After 5 seconds, the trolley stops and the pump will start spraying for 5 seconds. This process will continue until the front ultrasonic sensor detect an obstacle. If the front ultrasonic sensor detect the obstacle, it will stop spraying and the trolley will reverse until the back ultrasonic sensor detect the obstacle. If the back ultrasonic sensor detect an obstacle, then the trolley will stop. It means the whole mechanism will stop.
For the thermodynamics part, this is the control volume of the closed casing that stores the battery and the Arduino. Control volume 1 is between the air inside the casing with the wall of the casing, in which the air inside the casing is actually the heat generated by the components. Meanwhile, control volume 2 is between the wall of the casing with the outside environment. This is the equation that we use to find the operating temperature of the components, and we derive this equation from the first law of thermodynamics. We get the operating temperature as 36.12 degrees Celsius, which is much lower than the maximum operating temperature of the components. Next, we use equation of heat transfer via convection to find the heat dissipated to the outside environment, and we get the value to be 2.01 watt. So, we conclude that we don't need forced cooling for our product because the component's operating temperature is much lower than their maximum operating temperature. However, the heat generated by the components is higher than the heat dissipated to the outside environment, so we need to maximize ventilation by creating holes at the casing to avoid heat to accumulate inside the casing. For the manufacturing analysis, the flow of the analysis is we started with the bill of materials for both the raw and outsourced materials. Then, we select the most suitable manufacturing process based on this bill of materials. After that, we created the manufacturing system flowchart as a guide for us to design the plant layout. So this is the manufacturing system flowchart showing the flow starting from the raw materials to the final product being dispatched to the customers. Lastly, this is our plant layout. For this plant layout, we are using process layout for the low volume production of our product.
So for ethic analysis, our system is designed to ensure compliance with Malaysian law and regulation. For example, the first one is the Pesticide Act 1974. Second one is the Environmental Quality Act 1974. The third one is the Use and Standard of Exposure of the Chemical Hazardous to Health Regulation 2000, and the last one is Occupational Safety and Health Act 1994. These laws are important because they focus on protecting the environment, safeguarding worker safety, and ensuring the responsible application of hazardous chemicals like pesticides.
Let's take a look at our investment and operation costs. The fixed capital investment stands at 120,000 ringgit Malaysia, covering essential initial expenses. Machinery costs are relatively modest at 17,300 ringgit Malaysia, reflecting our investment in efficient equipment. Raw material costs amount to 1,844 ringgit Malaysia, indicating a cost-effective supply chain. The largest component is the operational cost, which is total 217 and 160 ringgit Malaysia, encompassing day-to-day running expenses. Adding all this together, the total amount comes to 356 and 304 ringgit Malaysia. This comprehensive breakdown helps us understand where our resources are allocated and ensures efficient financial management. This slide presents the analysis of the payback period and return on investment for the project. First, we can see the cash inflows, outflows, and net cash flow over the 5 years. The present value of cash flow is calculated using a discount rate, and the cumulative cash flow tracks the recovery of the initial investment of 538,860 ringgit Malaysia. Next, the discounted payback period is calculated as 1.2 years, meaning that the project will recover its discounted initial investment within just over a year. And finally, the ROI is calculated at 10.5%, showing a positive return relative to the investment. This indicates that the project is both financially viable and profitable. Now, let's begin with SWOT analysis. Starting with strength, our focus on research and development ensures continuous improvement in product performance and safety. In competition, our products stand out due to its emphasis on safety and quality. Moving to the weaknesses, our R&D is largely focused on our main product line, which is innovation in new items, and we struggle to compete with price-driven clients. Opportunities arise in technology, where Stella leads with high-quality products featuring advanced safety features. Lastly, consumer trends reveal that while the dealerships prefer our recommended product, many Malaysian consumers are unaware of the available brands, posing a threat. Rapid technological advancement could also render our current technology obsolete.